In this video, we are going to see about goodness of fit test in hypothesis testing. What is goodness of fit test? The goodness of fit test is a statistical hypothesis test to see how well sample data fit a distribution from a population with a normal distribution. Put differently, this test shows if your sample data represents the data you would expect to find in the actual population, or if it is somehow skewed. Goodness of fit establishes the discrepancy between the observed values and those that would be expected of the model in a normal distribution case. In this type of hypothesis test, you determine whether the data fit a particular distribution or not. For example, you may suspect your unknown data fit a binomial distribution. You use a chi-square test, meaning the distribution for the hypothesis test is chi-square, to determine if there is a fit or not. Goodness of fit test is used when you are comparing only one categorical variable. The chi-square test for independence compares two sets of data to see if there is a relationship. The chi-square goodness of fit is to fit one categorical variable to a distribution. Formula for goodness of fit test. The formula for chi-square is where C equals degrees of freedom, O equals observed values, E equals expected values. Examples of goodness of fit test. Example 1. A retailer wants to know what product offering appeals to young people. The retailer surveys a random sample of old and young people to identify which product is preferred. Using chi-square, they identify that, with 95% confidence, a relationship exists between product A and young people. Based on these results, it could be determined that this sample represents the population of young adults. Retail marketers can use this to reform their campaigns. Example 2. A small community gym might be operating under the assumption that it has its highest attendance on Mondays, Tuesdays and Saturdays, average attendance on Wednesdays and Thursdays, and lowest attendance on Fridays and Sundays. Based on these assumptions, the gym employs a certain number of staff members each day to check in members, clean facilities, offer training services, and teach classes. However, the gym is not performing well financially, and the owner wants to know if these attendance assumptions and staffing levels are correct. The owner decides to count the number of gym attendees each day for 6 weeks. He can then compare the gym's assumed attendance with its observed attendance, using a chi-square goodness of fit test for example. With the new data, he can determine how to best manage the gym and improve profitability. Example 3. Research question. An office claims that there is equal number of male and female employees in company. Solution. Here we have only one category, which is gender. We can apply goodness of fit test to see whether this claim is correct or not. We have taken a sample of 20 people, we got 11:9 ratio employee. This may be correct. Again, we have taken a sample, we got 12:8 ratio employee. This also may be correct. Again, we have taken sample, and we got 13:7 ratio employee. This may be correct or may be not. So we can't say that the 50:50 claim is correct or not. So we need a test to confirm this claim. Here we will use goodness of fit test to validate this claim. Step 1. Define null and alternative hypothesis. Null hypothesis, observed values equals expected values. Alternative hypothesis, observed not equals to expected values. Step 2. We sampled and collected data of 20 employees, and it comes out below ratio 13 male and 7 female, 13:7. Use the below formula to find the chi-square value. Here we got the chi-square value of equals 1.8. Calculated chi-square equals 1.8. Degree of freedom equals number of categories minus 1 equals 2 minus 1 equals 1. Step 3. Use the chi-square table to find the critical value for 3 degree of freedom and 0.05 significance level. Here we got critical chi-square value equals 3.841 and calculated chi-square value equals 1.8. If calculated chi-square value less than or equals to the value in the chart, we cannot reject the null hypothesis. Our null hypothesis, observed equals expected. Alternative hypothesis equals observed not equals to expected. Conclusion. As our calculated chi-square value 1.8 is less than the critical chi-square value 3.841, we cannot reject the null hypothesis, which is there is equal proportion of employees in our office.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.